So let's continue with the next lecture of WaterGEMS software by Bentley, which is reporting results. So in this lesson we will learn that how to compile the results which we have got after running the analysis in the previous lessons. Like in the previous lesson number 3 we did the scenario and alternate management. So now we will be learning in this lesson that how to interpret and how to compile or modify the results, which are the various output which we can get in the WaterGEMS software after running the analysis. So let's move on to the software. So in this, for this I have opened my file lesson number 3. Like as we did in the previous lessons, I will be continuing my lesson with this particular model which we did in lesson number 3. So first I will create a copy by using save as. So I will create a copy of this file and rename it as lesson number 4 reporting results. So now my file has changed to lesson number 4. Then I will change its title by going to File, Project Properties. Okay, so now we will start with this lesson. So first what I will do is, first I will run the analysis for a particular scenario and then I will generate its report. I will show you how to compile the report and what other output we can change and which we can get. So go to analysis, scenarios. So I'll be selecting this main scenario which was fire flow is 2000 liter per minute, and I will be computing the scenario. So now I have analyzed this model. Now I will go to report and scenario summary. So after doing the analysis, I will generate a report of what result which we have got. So that will open up. Okay, so this is the summary of the report which we have got. So you can see that our scenario was this 2000 liter per minute fire flow, and all the other parameters which we had defined while defining this scenario are enlisted here, and the summary has been shown here. So this is how the report is generated. So now you can save this or print this directly, this particular file, and you can save it and compile it later on. Okay, so you will save it by clicking on this icon. You can print it. Okay, so this is how you generate the report. Similarly, I can generate reports element wise also. So go to report and then element tables, and you can see all the different elements which we have, which can be provided in WaterGEMS. So I will just select any of the element which we have provided. So I will be selecting the tank. So this will generate report for all the tanks which are present in our model. So our tank was only one, which is T1, and we can see its different values. So these were the input values. Okay, so this is how we get the result. Now I can go to report, and then you can report the current time step or all time steps. So difference is that in the current time step you will get the functioning or the output of the tank at a particular time only, and in all time steps we will get the function or the output of the tank throughout our time being for which our software has been running, or whatever we have whatever time we have assigned. So I will go to report all time steps. So it will again generate the report for this particular tank. You can perform this step for any of the elements which are present in your model, like you can choose tank or pipe, etc. So you can see that for different times, like current time 0 hours, 1 hours, 2 hours, up to 24 hours, you can get report for each hour for this particular tank. Similarly, you can get the report for other elements also. So you can again save this or print it directly. Okay. When we will do the current time step by going to report and report current time, then we will get only the report for a particular time, which is the 0 time. So as you can see, this will be the current time 0 hours, so you will get the report for tank for that. So you can save this also. So this is how we report the results for our elements. Now we will be doing the editing or reporting of the flex tables. So I have told you about the flex tables earlier also. So flex tables are basically the tables showing the properties of all the hydraulic elements together. For example, so I will go to this flex tables here, and for example I will select pipe table. So all the pipes which are present in my model are shown here with their individual properties. Okay, so this is a flex table. So what we will be learning in this topic is that this is flex table is used when we have a large number of elements in our model. So this model actually is quite small. It has only 10 pipes, only one tank, and only 6 joints, but our model can be very large. So what if I want to, for example, I want to edit some of the pipes, like only 2 of the pipes I want to edit. For example, I want to edit the diameter of pipe number 9 and pipe number 5. So what we can do is we can just click on the pipe number 9, and I can edit whatever property which I want to change. Like if I want to change the diameter, I can change it. But if I want to change, if my model is of 10,000 pipes and I want to change the pipe diameters of 500 pipes out of those 10,000 pipes, then it is not humanly possible for us, for me or for you, to select each pipe individually and then change that parameter. So this is so for that we use the flex tables. So if I open let me open a flex table for a pipe. So we can edit the or enter the values of a particular element directly through the flex table also. So flex table has two parts. One is the input values and other is the output values. So as you can see here, the input value is, for example, we had assigned diameter to our pipes. So this is the input value. Material is also input value. Okay, but the flow, the velocity, the head loss gradient, etc., all these are the calculated results. Okay, so if you see here, the tables or the columns which are shown in yellow are not editable. So if I click on this table here on this row, and I'm pressing my keyboard here, so I am not able to change this value. So this is a uneditable input. But if I want to change the diameter, it is white. You can see the background is white. So I can change it to 400 also, and any value which is desired. So this means that white columns are showing the editable values and the yellow one is showing the uneditable values. So these values are generally calculated itself by the model. For example, this when we if you remember, when we drafted this model, if I make a line between J1 and J2, that is basically a pipe, so it will automatically give the start node as J1 and stop node as J2. So we are not inputting it ourselves, we are just uh, creating a line or a element or a pipe. It is assigning the start node and stop node itself. So whatever the WaterGEMS software is doing itself is in the yellow, is the yellow portion. When we have run the analysis, the head loss, gradient, velocity, etc. will be automatically calculated by the WaterGEMS software, and we will again not be able to edit these. So these are the calculated outputs or results. So when I enter any data in my table, like for example, if I want to change this diameter to 160 mm, so if I change it here, automatically it will be assigned to that pipe. For example, it was for pipe number 5, so it will automatically get assigned. Okay, so right now I don't want to change this, so I will again write it as 130. So now we will be learning about global edit and global filter. So if you have worked on MS Excel, you must be knowing what is the filter button there. So if there are a lot of values and we want to filter them according to a particular value, then we used the filter option in the Excel. Similarly, we have a global edit and global filter option in our WaterGEMS software also. So we will be learning that using an example. Okay, and obviously this global edit and global filter are used whenever network is very large, but I will be using this here also so that we can learn. So let us take an example. For example, I want to evaluate my model, that how this network will work and operate in 5 years. Okay, so I have prepared this model and I want to know the output, that how we will work it in after 5 years. So what I will do is, so let us create a situation or assume a situation in which that the C factor of an iron pipe. Okay, so let me first open the flex table again. So as you can see, some of the pipes were iron pipes and 2 of the pipes were PVC pipes. So let us assume a situation, then in 5 years the C factor or the Hazen-Williams factor for my pipe is going to change due to age. Okay, so as we know that every material is degradable, or it is not completely durable all the time. So if the Hazen-Williams constant of the iron pipe is going to change from 130 to 120 in 5 years. So let us take this situation. So one option is that I will myself input all the values. Okay, so now my value has changed to 120, so I will write it here 120, 120, etc. for all the pipes which are iron pipes. But again, as I told you, this is a cumbersome task when we have a lot of pipes and we have a very large network. So in that case, what we will do is we will use the global filter option. So in that case, what I will do is I will filter out the PVC pipes. Filter out means that I want to change the property of only iron pipes. So I want to select iron pipes only, then I can globally edit its values. But here we have 2 PVC pipes also. So what we will do is we will filter out these pipes like we do in Excel. We filter out PVC pipes and we will get only the ductile iron pipes, and then we can change the values of all these values to 130, 120 in one step only. We don't need to write 120, 120 again and again. We can do global edit and global filter in one step only. Okay, so what we will do is first we will filter out the PVC pipes, and then we will use the global edit tool to change the C factor of the ductile iron pipes only in one go only. Okay, so before this, what we will do is, as in 5 years this value will be changed, so this will be a new scenario or a new alternative. Okay, the current alternative is that the Hazen-Williams constants are this 130 and 150 for pipes, PVC pipes. But let us, as we always keep in mind that whenever we are using WaterGEMS software and we want to create another situation, so we will have to create a scenario. So I am going to create a scenario as we learned in lesson number 3, that now my C value has changed to 200 mm for some of the pipes, okay, and to the iron pipes, right? And then I will create, first I will create scenario, then I will create the alternate, and then for that alternate I will analyze, and for creating that alternate or scenario I will be using global edit filter and filter tool. So first of all, let us create a alternative first. As you know that first we have to create an alternative, so go to analysis and alternatives. Okay, now select this physical alternative which we had created in the previous case. So select this and create its new child alternative. Okay, so I am going to rename this child alternative as 5-year-old. So now my ductile iron pipe is 5-year-old and some parameter is going to change here. Okay, so 5-year-old ductile iron pipe, this is my new scenario, new alternative. Okay, so now I will create new scenario. So again I will create a scenario of this P8 and P9 and create new child scenario which will be same 5-year-old ductile iron pipe. Okay, so now I will click on this and I will have to change the physical parameter because physical alternative for this scenario is changed. So I will select here a 5-year-old ductile iron pipe which we have already defined a few minutes earlier. Okay, so this scenario has a physical alternative which we have defined, which is 5-year-old ductile iron pipe. Now we have to define that what is happening in this alternative. Okay, so for that go to report, element tables and pipe. So this is basically flex table of the pipe table. You can directly open the flex table by this icon also. So this is the flex table. So now I want to filter out the PVC pipes, as we have assumed a situation that in 5 years only the ductile iron pipes material will change its constant, which is Hazen-Williams constant C factor. So what I will do is I will just filter out the PVC out of this column and we will be remaining with only the ductile iron pipes. So for that what we'll do is right click on the material, because we click on the material column and right click on that and choose filters and custom. Okay, so now I want to create a filter that it will sort out all the filter of all the PVC materials, filter out the PVC and only we will get the ductile iron pipe. Okay, so this the query builder will open up. Now double click on the material. So from the field option I will search for material. So this is the material.
double click on the material, and here we will get physical underscore pipe material. Now click equal to sign, write down equal to. Okay, you can write down also, and you can just click on equal to sign also, and then click on this refresh unique values button to select the unique values of the materials. Okay, so this is the green button you can see here, so click on this. So the unique values for our material are only two here, which are ductile iron and PVC. So double click on the ductile iron, because what we want to do here is that we just want that our ductile iron pipes will be shown here and the PVC pipe will be filtered out. So we will select, write down here ductile iron, because we want only ductile iron to be shown here. And then so our command will be physical pipe material is equal to ductile iron. Okay, so as you can see, what happened was the PVC material got filtered out. So the PVC pipe are not now here. Only the ductile iron pipes are remaining. Now that we have filtered out the PVC pipes, we are left with only ductile iron pipes. So now we will use the global edit feature of WaterGEMS to change all of these values together. So we want to change the Hazen-Williams constant from 130 to 120 due to the age of the pipe. So what we will do is right click on the Hazen-Williams C and go to global edit. For the global, click on the global edit and you will get a dialog box. So in this, keep the operation set value as 120, because we want to set the value to 120 where physical pipe material is equal to ductile iron. So for the material which is ductile iron of the pipe, the value of C will change to 120. So now I will click on OK, and as you can see, all the values have now changed to 120 on a single click. So you don't have to change each and every value individually. You can just do it on one click using global edit feature. So this was the global filter and global edit feature. Now if you want to see all the pipes together, here now we have only the ductile iron pipes, but if you want to see all the pipes together, you will have to reset the filter. Right now we have applied a filter that only ductile iron pipe should be visible. So now you can reset the filter. So click anywhere, right click anywhere and click on filter, which is currently showing active because you have applied a filter here. Now I will click on reset. Are you sure you want to reset the active filter? Yes. So now we have got all the values. So these are actually all the pipes present in our water distribution network. Out of these, we had changed ductile iron pipe property from 130 to 120. Rest of the values of PVC pipes are same. So this is the global edit and filter. Now there is another property of WaterGEMS. I will again open the flex table for pipe. So go to this edit button here. So here you can see there are it is written here available columns 148. So there are many properties written here. So what are these properties actually? First look at this right hand side, selected columns 15. So these 15 columns are actually the columns which are present in the pipe table. That is the ID. So this is the ID, then label, material, length, scale, start node, stop node, diameter, etc. So these are all the properties of the individual pipes which are initially present in the flex table. Okay. If I want to add some property, and one more thing is you can see here that some of the properties are shown in white. As you can see here, this is white, and this is yellow. Length is yellow, flow is yellow, velocity is yellow, head loss rate is yellow. So yellow means it is non-editable, and white means it is editable. So these are properties which are present. If I want to add or delete one of these properties from the flex tables or more than one properties, I will use this edit command. So as you can see here, we have a lot of properties here. 148 columns are present. So let us assume that I want to add, uh, wait, I want to add the annual expected cost of the pipe to this flex table. So what I will do is I will click on annual expected cost and I will click on add. So what will happen? Another column will get added in the flex table of annual expected cost. So this is also yellow because its cost will be automatically calculated from WaterGEMS. If I want to remove it, then I will click on remove and this sign. So it will get removed. Okay. If I want to add all of these properties together, I will click on this double arrow here, add and double arrow. So all the 148 properties will be added in the flex table, which is not required actually. So this is how we can use the edit command of the table. You can also shift the uh, position of the column in the table. For example, if I want to uh, keep this material at the second column. So what I will do is I will click on the material and I will click on this up arrow. So what will happen? The column of material will get shifted up above. Or if I want to move it below, then it can get shifted. So if I click on OK, then you can see the material column has shifted now to the right hand side. So this is the edit command of the table. So this all depends on the user requirement, which value do we want to be displayed. So now that we have assigned the C factor of the pipes, which was a new situation, a new scenario and new alternative for us. So I will click on scenarios and then click on batch run and I will click on 5-year-old ductile iron pipe. This was our scenario which we had created. So I want to analyze this scenario. So I will click on batch, yes, and the WaterGEMS will calculate analyze this water distribution network for this scenario. So you will get this result. So this is how we can do things easily in WaterGEMS. Now next is print preview option, another option in WaterGEMS. So go to file and print preview. So in the print preview, it will show whatever we want to print. So it will take some time to open. So we can see before printing what the WaterGEMS will print when we give the print command. So it is opening right now. So this was about the print preview command. Now the next feature is how to create profiles in WaterGEMS. So profile basically means if we want to see the variation of our hydraulic grade with respect to the our elevation, because this is basically the plan of our water distribution network, but actually all these elements are at different elevations. and the water will flow through these pipes and will follow a particular hydraulic grade. So if we want to see its behavior, we will create the profiles. So for that, go to view and click on profiles. Now this will open up a dialog box of profiles. So click on new and it will create a profile setup. So it will ask us to select from drawing. So basically what this means that we have to select the elements from the drawing for which we want to create the profiles. So I will click on select from drawing and I will click on the elements for which I want to create the profile. So for example, I am clicking on P5 and P6. Okay, for now I'm a P5 and P6. So these are the two elements which I have selected, and I will click on this green tick mark to certain that I have selected these two elements. So I will click on this. So the WaterGEMS had selected these elements. One is P5 and another is P6, which are joined by these junctions J1, J4 and J3. So now I will go to open profile. So now WaterGEMS will open the profile of these elements. I will click on OK, and this is the profile which I have got. So what does this mean is from junction J3 to J1 we have two pipes here. So this yellow line depicts the elevation change and the hydraulic gradient is denoted by the red line, by the blue line. So this is the elevation. For example, you can see a slant here and here also. So this is according to the elevation of these specific junctions. So if I click on this green button here, this is a play button, you will see, as you can see, the hydraulic gradient line is moving. This is because this is the animation feature in profile which will show you the change in hydraulic gradient with time. You can see here time also. So if I play this, the time will also start to change. So I will have to move it to initial 0 time, and when I play this 1, 2, 3, 4, 5, 6. So from 0 to 24 hours it will show the behavior of hydraulic gradient. Note here that the elevation will remain same because it won't change with time, of course. The junctions will not move, so the elevation will remain fixed, but the hydraulic grade will change according to the flow of pipe in the water distribution network. So this is how you create a profile in our WaterGEMS. If you click on this data will show you the different values or from which this graph has been plotted. So as you can see, from 0 to 24 hours, uh, 0 to 24, the different hydraulic gradients and elevation has been shown in this particular table. So this is the hydraulic gradient of junction J3. This is the elevation of junction J3. This is hydraulic grade of J4, elevation of J4, hydraulic gradient J1 and elevation J1. So all the elements which you have selected, their properties will be displayed in the profile view. So you can just take a screenshot of this graph, or you can change the profile series and the chart options too. Okay, like which color is representing which line. You can all you go through these editing features. Okay, so this is about how to create the profiles. Now we move on to the next part, which is creation of contours. So how to create contours? So contour are basically the lines, imaginary lines, which are joining the points of same properties. Now we are studying a water distribution network, so there those properties can be the elevations of different points of water distribution network, or the hydraulic gradient also. Also, there can be many other properties which can be displayed through the contours. So how to create the contours? For that, go to again view and next contours. Then click on new. So now we are creating a new contour. So first of all, you will have a dialog box will open in which you will have to select which property do we want the contour to depict. So as you can see, these are all the different types of properties which can be shown with the help of our um, contours. So I will select hydraulic gradient from here. Okay, so this is hydraulic gradient. So this contour will give us the points having same hydraulic gradient. Now selection elements, in the selection set, select all elements. Now click on initialize, full range. So why did I click initialize? This is because the WaterGEMS will automatically see and search for the minimum hydraulic grade and the maximum hydraulic grade. So it will create contours from 198 meter to 222.76 meter. So we don't have to ourselves search for the minimum and maximum values of hydraulic gradient. We just have to click on initialize and the WaterGEMS will do its work and it will show us these values. Now the increment means that what will be the spacing between two contours for which each contour is represented. Now click on color by index. So color by index means it will show us the different colors of different values. Also click on smooth contours. So by clicking on smooth contours, we will improve the appearance of the contour. Now click on apply and OK. So now you can see here the different contours present in all of the elements uh, showing the points of same hydraulic gradient. So you can zoom it more to get the better view of the contours. So this is how contours are created. Similarly, you can create the contours for different types of properties, for elevation, etc. Okay, so you can get those values too. So this is about the creation of contours. Now next comes the element symbology. So what does element symbology means? Element symbology is automatically opened in WaterGEMS by default. So you can see element symbology is this tab which is always open in WaterGEMS. Okay, if you want to close it, then you can open it by going to view and element symbology. Okay, so what does this feature mean? So this element symbology is representing all the types of the elements which are present in our water distribution network. So for example, in our water distribution network, so first of all I will remove these contours so that we will have a clear view. So for removing contours, I will go to contours and I will delete the contour which I had defined. Okay. So now for example, I want to label my water distribution network. That is, for example, I want WaterGEMS to display the material of the pipe along with the pipe. For example, if P5 is PVC, then I want that it should be labeled here. Okay, so what I will do is I will go to element symbology, click on new and new annotation. So from new annotation I will select the property which I want to get displayed in my water distribution network. So I want the material to be displayed. So I will search for material here. So this is the material and I will go to apply. Okay. So as you can see, uh, for each pipe, its material is now being displayed. So I can shift it also so that there is not there is very congested here, so I can shift it also like this by moving the cursor. Okay, so if I again want to display the diameter of the pipe, then I will go to pipe diameter, and I will go to apply. So the pipe diameter will also get displayed here. Okay, so this is so now when you go to pipe, you can see the material and diameter. That is, material has been labeled, diameter has been labeled. You can delete this also. Okay, and you can edit it also. Okay, so you can edit all these also. So if I want to move these labels away from the pipe, then we will enter the values of x offset and y offset. So you will have to explore all these. Okay, so this was about annotation in element symbology. Now the last is color coding. So color coding means that if I want WaterGEMS to display my different pipes in different colors. For example, if you see this diagram now, you are not able to distinguish between P5 and P10 and P7. For now, all these are same. But if I want that the user can clearly distinctly distinguish between all these elements by using color, then how I will do that? So for example, I want that pipes are distinguished according to their pipe diameter, or similarly, as I told you in case of annotation, you can also classify or distinguish them according to different properties. For example, you can keep the PVC pipes in one color and the ductile iron pipe in other color. Okay, but always make sure remember that you can have only one type of color coding at one time. So what I will do is, again, so if I want to create the color coding for pipe, then click on pipe and go to new and new color coding like you did for new annotation. Okay, so first of all select the field name. Field name means the property which you want to distinguish on the basis of color. So I want to distinguish the pipes on the basis of their diameters. Okay, so what I will do is, first of all, uh, first let me open the pipe flex table. So see here, we have all these pipes of these diameters. So we have basically 1000 meter as the diameter and 150 also as the diameter. Okay, so what what we will do is we will put the color coding for these two values. So new color coding for diameter. So there are two values available with us. One is 150 and I will click on new. Another is 1000. Similarly, if you have other pipe diameters in the network, you can add those also. So assign the suitable color according to your choice. So I will select red for 150 and blue for 1000. So when I click on apply, you can see that all the 150 mm pipes, sorry, yes, 150 mm pipes are depicted by red color, and 1000 mm pipe is depicted by the blue color. Okay. Now, for example, we have a very complex system of pipes, and we have many types of pipes ranging from diameter 150 to 1000. There are many pipes within this range. Of some are of 180 mm, some are of 200 mm, some are of 800 mm. So for that, what you will do is you will click on calculate range and full range. Okay, and click on apply, and then click on initialize here. So what will happen, according to WaterGEMS will automatically create some ranges of pipe, like the if a pipe diameter is greater than or less than or equal to 320, then its color will be green. If it is between 320 to 490, it will be blue. Then 490 to 660, it will be navy blue, and so on. Okay, so you can see now that our these pipe diameters were 150, so these come under less than 320. So they have changed now to green. So this will be useful when we have a very large type of distribution network. Here in this network we had only two types of pipe diameters, so that it wasn't much fruitful here, but this is how you can do the color coding. Okay, so I will delete this for now. I will just keep two colors, that is 150 was one and the other was 1000, and I will choose some suitable color for both of these, red and blue, and apply. Okay, now if you now what does the red means and what does this blue means? uh, User is not able to distinguish by this. User can distinguish that red is some other and blue this is some different type of pipe, this is some different type of pipe. But what is the difference, that is not yet visible. So for that we can create a legend. Okay. So click on pipe and the color coding for diameter has been done. So right click on this and insert legend. Then it will ask you to select location, that where do you want to put this legend. Sorry. So this is the legend now, that if the diameter is less than or equal to 150, then it will be red. If it is less than or equal to 1000, then it will be blue. So now you can clearly see what does red mean and what does the blue means. So similarly, this you can choose different values and use different color coding according to your requirement to make the water distribution network, and by making WaterGEMS as more and more user friendly. So there are many such advantages of WaterGEMS, that in what way you can report the results according to your choice. So this was our this lesson on reporting results.